Well, hello, it's me, Mrs. Hoekstra. I'm working on Module 2, Lesson 12, Division of Integers. I'm on page 72 of your book, right? Lesson 12, Division of Integers. So we're changing it up again. We went from multiplication, now we're heading into division. How are division and multiplication related, right? How are these two concepts related to one another? We'll figure that out today. All right, exercise 1. Recalling the relationships between multiplication and division. Okay, I'm going to give you a list of some facts that are related to one another. And let's write those down in this rectangle that says equations. All right, let's list some facts. So, for example, 4 times 6 we know is equal to 24. And then if I use the commutative property, right, I could also say 6 times 4 is also related to that same fact because they both equal 24. Another way, because I want to try to figure out how multiplication and division are related, another fact that would be similar to this would be maybe 24 divided by 6 equals 4. And then I could also do 24 divided by 4, which equals 6, right? All of those are related to one another using multiplication and division. All right, so notice I have some directions in my book that you don't have in yours. And it says, using my equations, those that I just wrote, write 3, only 3, similar integer multiplication problems. Using two of them have to be using one negative number as a factor, and then the other one of those two has to have both negatives. Okay, and don't forget you can use the commutative property if you need to. Okay, so I want you to hit pause. We're going to hit pause, and I want you to try to figure that out. And when you're done, you can compare your answers to mine. All right, hit pause. Okay, so there are mine. All right, so again, I actually have 6 there, but you only need to give me 3. So my first one is negative 6 times a positive 4 gives me negative 24. Or 4 times negative 6 is negative 24, just depending on if you wanted to put the positive 4 first or the negative 6 first. It really didn't matter. My second one, I did change it. It's a positive 6 and a negative 4, right? Then I get negative 24. Again, I could have had the negative 4 first and the positive 6 second, and I still get negative 24. Then the last one did say that they had to both have negatives. And so I have negative 4 times negative 6 is positive 24. Or again, you could have used commutative property and flipped those around and had negative 6 times negative 4. All right, so those are my 3. Check to see if you have the same ones. If not, hit pause again and fix them. Make sure that you have the right ones. All right, I, on the other hand, am going to go on to the next page. All right, so again, I have some directions here. We'll talk about those in a second. We're going to record those sentences that we just did a minute ago, the ones that were in the integer bubble, and we're going to record those in the equations now. So we're going to take the ones from the other page. So I'm going to take negative 6 times 4 equals negative 24. There's 1. I'm going to take the negative 4 times the positive 6 and write negative 24. There's my second one. And then the third one did mention that they had to both be negative. So negative 4 times negative 6 equals positive 24, right? That was from the other page just a second ago. All right, now what I want you to do, I have the directions up here, right? Use the same multiplication facts in the previous bubble, which we just wrote down now, to write 6 related integer division facts. All right, this time we're doing 6 of them. So in other words, 2 for each of these, right? I want 2 for that one, 2 for that one, and 2 for this one. And it has to be division. All right, so rewrite those in division. Again, hit pause. Fill that in and see if you and I have the same answers. Hit pause. All right, so here are my answers. So I have negative 24 divided by negative 6 equals 4. I put the negative 6 in parentheses just so you guys don't get confused why there's a division and then what appears to be a subtraction sign. It's not, it's a negative. You didn't have to, but it does make it a little easier to understand what's going on. Negative 24 divided by the positive 4 right? Because there's a positive 4 in the original red problem there. That equals my negative 6. So all of my numbers, my integers all stayed the same in that example. My second one, negative 24 divided by negative 4 gives me my positive 6. Or I could have said negative 24 divided by the positive 6 gives me my negative 4. And then lastly, the positive 24 divided by the negative 6 gives me a negative 4 answer. And then the positive 24 divided by my negative 4 gives me a negative 6 as my answer. All right, so we've kind of looked at how these things all kind of interrelate to each other, right? So it says list examples of division that produce a quotient that is a negative number. So we're going to look at all the ones in which I got negative answers, right? I want all the ones that I got negative answers. That one was a negative. That one was a negative. And both of these gave me negative answers, right? So negative 24 divided by a positive 4 gave me a negative 6. And a negative 24 divided by a positive 6 gave me a negative 4. And then I had positive 24 divided by negative 6 gives me a negative 4 answer. And then lastly, 24 divided by negative 4 gave me a negative 6 answer. All right, look at all of those. What's up? What do you notice about the signs, positive, negative signs in all of those? Okay, if the quotient, the answer, is negative number, what must be true about the dividend and the divisor? What do you notice about those sets of numbers? Negative, positive, negative, positive, positive, negative, positive, negative. The signs were always different, right? The signs are different. One's positive, one's negative, or one's negative and one's positive, however you want to say it, but the signs are different, aren't they? Okay, that's kind of important. Signs are different to get a negative quotient. All right, well then let's list all the ones that give me a positive value, right? Let's go back up here. Look at all the ones that gave me a positive value. Positive. That one gave me a positive. I'm actually going to toss in 2 more just to kind of help us find the pattern, I think. But the ones that gave me the positives was negative 24 divided by negative 6, and it gave me a positive 4. And then I had negative 24 divided by negative 4, and it gave me a positive 6. And then I'm going to toss in 2 more that aren't up there, but they are facts. You know, 24 divided by 6 gives me 4. And I could say 24 divided by 4 gives me a positive 6. Okay? Well, you know what the next question is going to be at the top of the next page, right? What do you notice about the signs? So before I flip it over, let's look at the signs. Negative, negative. The next one. Negative, negative. Look at the next one. Positive, positive. Positive, positive. Look at those signs. The first 2 were both negative. The second 2 are both positive. So what could I say? I can say that both the signs are the same. Both the signs are the same to get a positive quotient. Okay, here's the big idea. Rules for dividing 2 integers. All right, rules for dividing 2 integers. Put a star, a smiley face, highlight it. Do something to make sure that this jumps out at you, especially as you're working on the independent practice when you come back to class. Okay, so if both sides are the same, let's just go with the one that's directly above us right now. If both signs are the same, the quotient is positive. If both signs are the same, the quotient is positive. All right, and same could be said if the signs are different, the quotient is negative. Okay, if the signs are different, the quotient is negative. Does that sound vaguely familiar to you guys? Like if you went back a few pages or a few lessons in the book, would you see something similar to that somewhere else? Right? Because remember, I originally asked you in your essential question, how are division and multiplication related? I'm not actually talking about the multiplication division facts. You learned those back in elementary school. But notice the sign facts, right? They should look similar or familiar to you from something we did earlier. All right, let's take a look at exercise 2. Is the quotient of two integers always an integer? Okay, now there's a couple vocab words in here, and some of you get it, and a handful of you, you're still struggling with even just the word integer. Okay, so let's explain integer before I have you guys try this out. An integer, in case you weren't sure, an integer is a positive or negative whole number. All right, positive or negative whole number. So if you were always like, she keeps using this word, but I'm not exactly sure what she's talking about, that's what I'm talking about. It does not include fractions or decimals. Okay, they're just positives and negatives, and they have to be a whole number. So I want you guys to read this question again. Is the quotient, right, answer to a division problem, always an integer? Use this space here to create quotients of integers. Answer the question and use examples or counterexamples, right, to support your claim. So I'm going to have you guys hit pause. See if you can figure out if it's always going to be the case. All right, hit pause. Okay, so if you actually tried this out, you may have found integer answers, right? I did. 4 divided by 2 is 2. Or negative 4 divided by 2 is negative 2. Those are integers, right? I could come up with thousands upon thousands of integer answers like that. But I could take those exact same two numbers and just switch them, right? I told you guys, I think before, commutative property doesn't work for division. I can't flip-flop them like I can with multiplication. So if I take 2 and divide by 4, I get 1/2. Or if I take 2 and divide by negative 4, I get negative 1/2. And based on the definition of integer, right, they're not integers because they're not whole numbers. Yes, they're positive and negative, but it's not a whole number. That's a fraction. Total different type of number to deal with, not called an integer, right? It's a number, just not called an integer. Okay, so there are my examples of it's possible, but it's also possible to not have an integer answer. All right, thousands upon thousands of possible answers. So you guys could have used different numbers. As long as you got some kind of a fraction or decimal, then yeah, you figured it out. Way to go. Okay, all right, let's go to the next page. We are almost done, guys. All right, exercise 3. Different representation of the same quotient. Are answers to the 3 quotients below the same or different? Why or why not? Okay, so let's try this out. I'm going to do this with you guys. So what is negative 14 divided by 7? So basically, what's 14 divided by 7? 14 divided by 7, that's 2. How many negatives do I have? I have different signs, right? One's positive, one's negative. So my answer is going to be negative. We'll take a look at the second one. 14 divided by 7, again, that's 2. But look at the signs. One's positive, one's negative. My answer is going to be negative 2. Now take a look at this last one. Notice where the negative is. The negative is outside the parentheses. So that, if you remember, please excuse my dear Aunt Sally, I got to deal with the parentheses first. So do the 14 divided by 7, and you actually get 2. And because the parentheses is outside of it, I can write it as, negative and then parentheses 2 or negative 2. So what do you notice? Are the answers to the quotients the same or are they different? They are all the same, right? They are all the same. They are all the same. The first two, what do you notice about them? The first two have different signs, right? The first two have different signs. So it's a negative quotient. Okay, so we get a negative quotient. What's up with that third one? The last one, what did we do? The last one, find the quotient, right? We did the division, find the quotient, then change it. Do you want to say to the opposite, or do you want to say make it negative? I think I'm going to say change it to the opposite. Then change it to its opposite. Right? Because remember, we say this means the opposite of. Opposite of. Right? So what's the opposite of positive 2? Negative 2. Okay, so do you think you guys can tell me how this is related to integer multiplication, right? Be prepared when you come to class to do this summary. I will see you all later.